Hey y'all, I'm Jay, the IP guy. Welcome back. Today I'm gonna talk about Ethernet, Ethernet protocol. So, quick question: what is Ethernet? Of course, we know what's net. That's net. Okay. So what's Ether? Ta-da! Which one? Which term is Ether? 3, 2, 1. The answer is reality journal. Look at here. Ether. Okay. Okay, second quick question. What layer Ethernet? What layer does Ethernet work? The answer is layer 1 and layer 2. Layer 1, something like cable, optical fibers, RJ49 or 45. Yeah, sorry. Yeah, and there's other protocols also, but Ethernet beat all of them. Okay, let's look at the frame. From this frame, we can see the destination. This is the MAC address. Destination MAC address, source MAC address, and the type, and the data union, and CRC. So this address we're gonna talk about later, and it's very important. And the type means what's inside the Ethernet packet. What's the data unit? Is IP? Is IPX or Apple Talk, IPv4 or v6? This one is to check the frame is okay or is it bad. Oh, one more thing is there's two type of mainly there's a two type of Ethernet packet, Ethernet frame. One is we call the DIX Ethernet, or you can call it the traditional or type 2 Ethernet frame, and that's three companies. I know the I means Intel. You can Google it if you're interested. And this the IEEE, the organization 802.3 Ethernet frame, whatever. But most of the time we use this one. We use type 2, the DIX Ether. Okay, let's look at here. What is MTU? It's a maximum transmission unit. What does that mean? Look at here. There's an Ethernet frame, and from here, this is the Ethernet header. This is the trailer. Where's the trailer? There's supposed to be a trailer over here, whatever. And if we cut the header and the trailer off, this is called IPMTU. Also, we can call it interface MTU, and but a TCP as a MWS is different. It's from it's not include TCP header, but IPMTU include the IP header. As here. From here we can know the data unit. Let's say this is an IP packet. The MTU is 1,500. But this one's a little bit different because because this number include LLC and PAD. And we can look at over here. This is a topology. This is the R1. No worry about commands. You can do it. But we're not gonna talk about the command, the syscall, this kind of thing, a lot, because we're focused on TCP/IP. Let's say interface one, so IP and MTU. You can set this MTU as a different number from 68 to 1500. So that's the MTU. You can set 1040, 90 or something like that. If I hit enter, it work. Okay. Let's go back here. And why is it important? Because if it's, let's say I type a Google and type in Google and hit enter, my packet goes through lots of routers, right? One of the routers MTU is not 1500. It might be 1400 for some reason. So the IP packet, they frame, have a problem. It cannot go through until you do this, fragment it. It's called a fragmentation. We can talk about this later, very kind of thorough. So right now, just know there's something like MTU. Now let's look at a packet. Let's get a packet. Not saving. But this time I don't need to wait a lot of time because that's very easy to get Ethernet frame. Look at here. Open it. This is the destination MAC address. The number is hexadecimal, and this one is my address, and this one, what is this? I'm gonna talk about this later. This is the tab. Is IPv4 is 0800. Let's get a IPv6. Look at here, the tab is different. It's 86DD. Okay. Ta-da! It's over here. This is a MAC address example. From there's a 48 bits, and that means 6 bytes. The first 3 bytes is called organizational unique identifier. Basically, some company or organization can buy it, and they can create a MAC address, burn the MAC address into the network card. This one is called network interface controller. So if another question is, I think I stated that before, but I have to correct myself. Is most of the time is globally unique. This address, your MAC address is different from mine, and different from Sam or Mike or whatever, and different you know, mobile phone or laptop, they have different MAC address. But there's a one thing, it's called virtual machine. So we can look at here. You can open the Windows command prompt, type in the ipconfig/o. Boom. There's a bunch of there's a bunch of MAC address. This is a Wi-Fi, but this one is a virtual machine. And this one's a virtual machine too. So since the virtual machine, you know, it just works in my laptop, you know. So if this one is the same as you know, Mike's laptop, you know, that's okay, because you know, that's in different VLAN, different network, right? And the other example is the Cisco. Cisco has some machine. They ask, you know, that machine ask you to type in the MAC address. You know, that's kind of cool, you know. Oh yeah, let's look at this. This is OUI, right? OUI. So look at here. Let's Google it. MAC address wonder. So look at here. It's registered by Hon Hai Precision Company. You can Google your you know, MAC address to see you know, what company made it. You know, WordShark also have this this function. You know, you can show the MAC address. It's over here, the Hon Hai something. Yeah. I think it's pretty cool. You know, you can know the company. Over here, let's say it's a very easy example about how the switch learn the MAC address, but I'm not gonna go deep over here, because I'm gonna talk about ARP later, very specific, you know. Let's say A send a packet to the switch, but this is the first time they talk to each other. This packet, this frame is called NO unicast. So the switch got this packet from the host A. So there's a in his MAC address table. So he knows it's port 1. Okay, port 1. You know, I got this packet from port 1, and who did this is host A. So actually, there should be the host A MAC address. And he got this, and he broadcast, you know, B got this. Oh, that's not mine. So drop it. D got this. Drop it. Oh, this is for C. For C, send another packet back. You know, so the port 3, from the port 3, the switch, oh, it is host C. Okay, I got you. And then forward this packet to the A. After that, A and C, they're both in the MAC address table. So the switch, will forward this unicast just between A and C and no broadcast. Oh, let's see this. Yeah. Let's over here. There's a switch. Here. I'm sorry. No. Show. Oh, let me type all of them. My address table. Enter. So we can see here. Over here. This the E00, E00, right? The MAC address, so PC1's MAC address is AABBCC00 and A000. How? Yeah, they are belong to the VLAN 1, and then they learn dynamically. And E01, so this PCB is MAC address. No worry about it. We're gonna go deep later. Maybe next time. Okay, over here we're gonna talk about a little bit about VLAN. Once again, maybe I'm gonna talk talk about CCNA later, but not right now. So just a very simple concept about VLAN. What's a VLAN? VLAN is called a virtual LAN. VLAN can create over here, create over there. This is a VLAN 10. Virtual LAN versus physical, because so this four hosts connect to this switch 12, but only these two in VLAN 111, and this PC and this PC they belong to another VLAN. It's a VLAN 10. Basically, this link, from the link is between the switch and the host. This one is called access. We can set the switch access mode in this port, and the link between the switches, like those, this is called the trunk. Trunk, is not only for one VLAN. Trunk is for all the VLAN. You can add whatever you want VLAN into the trunk, But how to know that? How to know that? Let's say the Ethernet frame just the address, the tab, and this one is the payload, and this one is the check. So how can they know there's a different VLAN? So that's the way people, the scientists, whatever, the network engineers, they created this, over here. This is the frame, right? Between the source address and type, they put a VLAN tag. There's a 4 bytes. 4 bytes means 32 bits. Yeah, And very important is this VID is a VLAN ID. Yeah. When the switch got a packet from the host, they will open it and put a VLAN tag over here and then forward it. Ta-da! It's a 1 minute break. Okay, I'm kidding. Here, there's a two trays, but focus on over here. This is the root. It's underground, right? But those the branches, right? Can you see a loop in the around the branches? No, there's no loops, right? Maybe there's some weird tree has which have loops in somewhere, I don't know. But this one, there's no loop. Remember this. They just from the root over here dot. So because I'm gonna talk about this spanning tree. Spanning tree is a logical. Let's say there's physically they connect to each other, right? So there's a lot of loops, like from here, from the right point, switch 12 to 13 to 15 to 12 again. So if there's a loop, so there's a problem. Let's say from the switch 12, they send a broadcast. What's a broadcast? Broadcast a unicast broadcast and multi-podcast. Unicast is from one to another one, right? Just 2 points. And broadcast is sent to everywhere in the VLAN. Let's say switch send the broadcast. So switch 13 got the broadcast, then they send out to the 15, the 14, and the 15 send that out, send it back to the 12, right? That's a loop already. And then to 16, 17, blah, blah. They already have a loop. And the 12 got this broadcast which is sent a few seconds ago, I guess. Then they send again, and the 16 got this, right? But 16 also got a 15th broadcast. He sent again. So over time, maybe just a few minutes later, there's a bunch of broadcasts. Then the CPU down, the memory crash, and the switch is down. Everything's down. So that's very serious problem. So we're gonna prevent the loop. Let's look at this again. No loop, so good, right? There's a loop, no. Okay, how can they do that? They use the spanning tree protocol to do this, and there's an IEEE something. Yeah, Google it if you're interested. And Cisco, they have their private spanning tree protocol also. Basically, they before they send forward those data, they connect to each other, right? They send the BPDU, they send the bridge protocol data unit to each other. They talk to each other. Okay, they select the root. I say this one's a root, and the root is the boss. So he no, it's not the boss anyway. And they'll block For example, I just give you example. It might not be correct. Once again, I don't want to go deep over here. And they block some ports, so there's maybe no loop. Once again, that's logical. Physically, they connect each other, but they use the protocol to block some ports. But if other ports, for some reason broken, this port can up immediately, maybe a few seconds. Yeah. Over here, very, very little about PPPoE. PPP is a point-to-point protocol. When you use the ADSL, probably you can use this protocol. Because let's say over here, this is the Ethernet frame. You cannot use this only Ethernet to type in your username and the password, but the PPP can help you to do this. So they add the PPP the packet over here, between the tab and checksum. So so after that, the PPE has some other field you can use, and there's something like authentication, and you can send the password. That means the username and the password, and like a comparison, something like that. It's basically more functions. Yeah. And one more thing is this Wi-Fi. We use everybody use Wi-Fi, right? But here's the big problem. Is the security. Why there's a security problem? First, it's a shared network. It's not like those kind of wired network. It's a wireless. Everybody. Let's say there's 10 hosts. They connect to this AP, wireless AP together. So the 10 hosts share the network, right? And they have to use something like this CSMA to avoid the collection, because you get a shared network. For example, the host A and the host B send a frame at the same time, just like two cars, go two cars. What is gonna happen over here? So crash, right? Boom. So they use some protocols to help them to avoid the collection. And one more thing is the hacker can use another AP, but the same SSID and the same name. When you connect to that one, you said that's the correct one. That's no problem. So there's a bunch of hacking technologies over there, but once again, that's not what I'm gonna talk about this time. Okay, most of the important thing is the Ethernet protocol, Ethernet frame, and a little bit about MTU, and the MAC address, and the switch. How the switch learn the MAC address, something like that. Okay, thank you so much.